In the last section, we talked about mixtures being two different samples that are put together. So here we're going to talk about mixtures, but we're going to learn to differentiate between mixtures and pure substances because those two words are often used interchangeably. A mixture is a combination of two or more substances. We know anytime we put two different things together, we're talking about a mixture of those things. A pure substance is something that has the same composition. So a mixture might be something like salt water. We have salt, which is NaCl if we're talking about table salt, and we're adding that to a sample of water, which is H2O. These are two compounds combined. So again, a mixture is a combination of two or more substances. We would consider salt a substance and water a substance, and when we put them together, we get salt water. A pure substance is something that always has the same composition. So a pure substance would be something like H2O or NaCl. These things have the same composition independent of each other, not when they are mixed together. They can't be separated any further by physical means. So I've already put them in their most basic form in terms of their physical properties. I can further separate them chemically, but not have them remain a compound when I do that. So we're looking at a mixture, two different substances put together, or a pure substance, something that has the same composition. We look at the difference between mixtures by looking at two different samples of cookies. So for example, the one on the left is what we would call a homogeneous or homogeneous mixture. So this refers to something that has the same composition throughout. So it doesn't matter if I take a bite of the sugar cookie from here or from here, it's going to taste the same. Either place I take a bite out of that. Another example of this would be something like peanut butter. Doesn't matter where you take a spoonful from the jar of a sample of at least creamy peanut butter, one taste will taste exactly like another taste from another place in the jar. Heterogeneous mixtures are what's known as variable composition. So a chocolate chip cookie would be an example of a heterogeneous mixture. Visibly different parts. So we can see that the chocolate chips are visibly different than the base of this cookie. I could take a bite from here and only get 2 chocolate chips. I could take a bite from here and get 0 chocolate chips. So the composition is going to vary based on the place that I take that bite from. If we're using our peanut butter example, remember homogeneous would be creamy peanut butter, so heterogeneous might then be crunchy peanut butter. Maybe one bite that I would take would have 0 bits of peanuts, and another bite that I would take would have a few more peanuts in it. So we have a chart that allows us to classify matter based on different characteristics. So we're going to start with our 4 basic samples of matter, and then at the end we're going to see where we can place them in our spectrum of matter. So we're going to look at the chocolate chip cookie, and we're going to look at the sugar cookie. We're going to look at just a sample of water, and then we're going to look at just maybe an element like hydrogen. So looking at the chocolate chip cookie, the sugar cookie, water, and hydrogen, we will then be able to see where we can put each of these samples in our classification scheme. Starting with just a sample of matter, the first question we want to ask ourselves is it uniform throughout? And if the answer is no, we're already able to place a heterogeneous mixture in this location. And a heterogeneous mixture, like we said, might be something like the chocolate chip cookie. If the answer is yes, is it uniform throughout, then we have a homogeneous mixture. So we can't automatically place something like the sugar cookie here because our homogeneous mixture can be a lot of different things. The homogeneous mixture can be the cookie, it can be salt water, it can be regular water, it can be hydrogen. So we want to break homogeneous, as far as is it uniform throughout, down into further categories. So if we know it's homogeneous and it's completely uniform throughout, we want to ask ourselves, does it have variable composition? If it has variable composition, then this is something like salt water. So that it looks the same throughout that whole sample, but the variable composition means it's made of more than one pure substance. Now, if it does not have variable composition, meaning it's not made of more than one different thing, then we have a pure substance. So if we're starting with pure substance now, we need to ask ourselves, can it be separated into simpler substances? Because a pure substance can be something like one type of element that makes up a whole sample, or it can be two elements put together that make up a whole sample. So if our answer is no, if we're talking about a substance that looks the same, that is not made of more than one different thing and cannot be separated into simpler substances, then we're talking about an element. However, if we're talking about something that looks the same, is made of more than one different thing, and can be separated into simpler substances, then we're looking at a compound. So now we have a place to put each of those individual items that we talked about. The heterogeneous mixture would be our chocolate chip cookie. The homogeneous mixture would be our sugar cookie, or salt water, as we discussed. The element would be something like hydrogen, and the compound would be something like H2O.